Okay, so another problem for determining, right, was it asking for empirical formula? Um, in the last one, we went from mass to mole and then a ratio. Here, we're given percent. So part of it is how we're going to deal with the percent issue here. And the other thing, notice the insert, there's this little table, and it's found in the textbook in one of the sections on the practice problems. So, and we'll refer back to it and you'll see in just a few minutes. So there's a couple different aspects here that we have to deal with. Okay, so this issue, what we find here is that, well, actually in some ways this is more typical that you find empirical formula, empirically determined information, the empirical data that's given to a lab of a new compound that they have characterized or they're wanting to characterize. And you send it off to a lab, they basically destroy it, and in the process they collect the mass percent values for carbon, hydrogen, oxygen, etc., whatever else is in that sample. And this is just sort of your run-of-the-mill hydrocarbon here, or not hydrocarbon, organic compound. And the way to handle this is to just imagine if you had sent in a 100-gram sample to the laboratory for them to analyze. If they took that 100-gram sample of ibuprofen, then what they would find is that they'd still get the carbon, hydrogen, oxygen, sure. And what they would find is that the carbon, what is 75.69% of 100 grams, that's easy. It's 75.69 grams. Hydrogen would come in at 8.80 grams, and then oxygen 15.51 grams. Very simple. Just replace the percent sign with a gram, and then you're on the same pathway as we did here. Let me quickly set that up. So I want to talk while I do it. So the first step is in all steps here. When in doubt, what do? I calculate the number of moles, and I take the atomic mass from the periodic table. I go to the hundredths position. Now, this one is not that important since this is really small, but in other cases it does become important. And I guess something I forgot to mention in the last video, but hopefully it's just something that you're in the habit of doing. We factor in the sig figs in our calculations. That becomes an issue with a lot of these examples because you need that accuracy in the data so that you can get to really, and a lot of times, to get your numbers just to work out well enough. If I just stopped this one at 6, I don't know if I would, get the clear pattern that I'm going to get once I try to find that smallest whole number ratio from this the set of mole values right here. Okay, so there's my problem, and I'm in the same spot that I was. Here I know. So this mole ratio, right? That tells you the ratio of the different atoms in your particular compound. Atoms show up as whole numbers. You cannot have you can't have 0.9694 atoms of oxygen just show up. All right. And so what do? We normalize the data, or at least that's the phrase I use. And I might be, if a mathematician ever listened to this video, I don't know, maybe using that phrase a little bit loosely. Who knows? Anyway, I'm trying to put it all to whole numbers, and the way I do that is I divide by the lowest number, smallest number here, in this case the 0.9694. I'm going to drop the unit here just for convenience, and plus I'm running out of room here. And then I sweep through the math, and what I find that 6.5. I can't have a half an atom of carbon, so we got to deal with that. This one comes in at well, I'll just 8.98. That is close enough to 9. All right, that's going to be 1. So again, if it's just just barely off of a whole number, don't worry about it. Round up, round down. Here you round up. In that last problem, we rounded down. Right? We just dropped this last portion. It didn't matter. It worked out just fine. Now, what's of more concern here is the 6.5. Again, I can't do this. This would not be allowed. Even though, I mean, in some ways, it's a true statement in a sense. It does represent the a ratio, sure, but it's not a whole number ratio. I need to get rid of that decimal there. And then also, just in a reality sense, you can't have, if I was given this and I wanted to draw ibuprofen now, I can't do that because a half a carbon atom just doesn't show up to bond with something. That's not how nature works. Okay, so we need to get rid of the decimal point. And notice what they're sharing with you in this little chart. If the decimal is 0.5, then multiply by 2. Let's just apply that and see what we get. Okay, and I'll go back and talk about it later. So let's apply that concept. I say, okay, I'm just going to follow my instructions here. I say I'm going to multiply that by 2, and I can't just multiply that by 2. I mean, this ratio is true, 6.5 to 9 to 1. If I do something, if I mathematically change one, I have to mathematically change them all, and that will get me to my 13 to 18 to 2 formula. And so again, that isn't the one. It would be what's given in the answer to this problem. It would be that. So what have I done? I've taken care of. I've removed my decimal value here by performing some mathematical operation to now get whole numbers, which is what I want, smallest whole number ratios for ibuprofen. Okay, let's just say a few words about why are we, I mean, it works out great, but why are we, how do we know? How do we know to multiply, if it's a 0.5 decimal, we multiply by 2, or if it's a 0.25, we multiply by 4. Where do these numbers come from? Well, they come from the fraction, and that should be a 3. And I'm writing these out because they're the most common. I mean, yeah, I guess occasionally you might see some of these other. I guess I have seen one of these two, maybe 1 or 2 times in a different class, a different textbook. Okay, but these are by far the most common ones that I ever come across. And where again, where do these numbers come from? Well, if it's 0.5, I multiply by 2. If it's 0.3, I multiply by 3. If it's 0.25, I multiply by 4. I'm just multiplying by the denominator in these for these fractions. That gets rid of the fraction. So anyway, just a little bit of background about where these numbers are coming from. Whatever number would be on the bottom of that being a fraction. Like for example, you know, what is 0.75? 0.75 is 3/4 if you put it into a fraction, and the 4 is coming from that lower number, and that's what you would multiply through all the way through. But again, these are the most common. The reason why I'm sharing these with you is because you're not going to have this table for the test. You need to know this as a concept and apply it to the problems that are on the test. And you know, I'm not a big fan of memorization, even though that may not be you may not feel that's the case with the nomenclature, but I'm not. But I do recommend at least these three. These three will get you through the vast majority of the problems that you'll come across in your chemistry classes. And that's enough for this one, I think. Okay, thanks.